Hey guys, good afternoon. I'll introduce myself and then we'll go over the securing agentic applications. My name is Vineet. I currently work at AWS on our application security team for some of our core big data services and Bedrock and Q. Outside of work, I like skiing, and I'll pass on to my co-lead, Idan.
Hey everyone, nice to be here today. My name is Idan Abler. I'm an AI security researcher at Intuit. Very excited to be here today, and I hope that we will have a great session as the following session is all about hearing you guys.
And my name is Rob Truesdale. I work at a company called Pangea. I've been working with these guys in the group now for about 2 months. Outside of this project and Pangea, I'm into anything outside. So yeah, love being outside. We're gonna break up the session. There's 3 parts. Vineet will go first, and then Idan, and then in my section. On mine specifically, just priming you all. We're gonna be very interactive, asking you about use cases and things that you're building as it relates to secure agentic apps. So maybe start priming your own mind on that, and we're gonna dive into that. So,
Okay, so as Ellen just demonstrated, 2 months ago, OWASP released the threat and mitigation guide for agentic AI, and John just left the room. He assigned us with a very important mission to complement the guide and providing practical recommendations and practical countermeasures that each of you can utilize to enhance the security robustness of your own applications. So in the next 30-40 minutes, we have 2 main goals to achieve. The first goal is just to walk you through our methodology, the methodology that we use to create a guide. Make sure that you fully understand it and you can consume it and use it wisely. The second goal is to have an open discussion to hear you all, gain your feedback, and improve the document before we will finally release it.
That QR code has a link to a feedback form. You can submit that anonymously or with your name. The feedback form at the top has 2 doc links. You can click on those, follow the doc as we talk along, so you actually can see what's going to come out. You can also provide comments as we go along. So we're talking about different sections in the doc. They'll be mapped, so you can stay along. Go ahead, Idan.
So let me try to explain you our methodology step by step. Our methodology consists of 4 different properties, which gave us the flexibility to cover many types of agentic AI applications. The first property is the development lifecycle. So as much as we tried, we couldn't identify any single silver bullet that mitigate the entire threat landscape, obviously. So the guide offers diverse solutions that could be spread among the entire development lifecycle, starting from the design and building phase till the runtime. And when focusing on the design phase, we are recommending examples for how to create secured prompts, how to differentiate your trusted data from your untrusted data. And when speaking about the runtime, we are offering recommendations on how to identify violations at real time. And for example, as content moderation, which tools are available out there and how you can use them. The second property are the key components. Over here, you can see a simple agentic system. This is our cute little agent. And it is composed of every key components that available out there. There's the LLM itself, a foundational model, the memory module, planning module, and the tools that the agent uses. Each of these components are very crucial to understand how the developer implemented them in your own applications, as each component exposing the application to different types of threats and different types of risks. For example, a memory module could be implemented as an isolated object or as a shared object. And if the developer chose to implement a memory module as a shared object, he can implement a shared memory among users or among sessions or even among agents. Each of these options exposing the applications to different attack vectors, and the guide that we are providing recommending on specific mitigations, tailored mitigations for each of these options. Okay, next. Yeah. So we couldn't ignore the architectures that we have out there. Yeah? Architecture is like a magic word. So the guide focuses on few different architectures, starting with the single agent architecture, which is the most simple one, and we are building upon it. Moving to the multi-agent architecture, with and without an orchestrator, if you're familiar with the swarm architecture that has no orchestrator. And obviously the state of art at the RSA conference, the peer-to-peer orchestrator, where two agents, agent A and agent B, directly communicating with each other without any intermediary or any proxy in the middle. And each of these architecture requires to put focus on other areas of your application. For example, a multi-agent application will require to put focus on how to harden your orchestrator, how to harden the communication between the agents that are communicating at the same application. And when we are moving to peer-to-peer applications and peer-to-peer architecture, we need to put focus on decentralized trust. How to gain decentralized trust between two agents that came from two other companies. So we are offering solutions like tool registries and agent registries. And our last property is the agentic skills. A skill is the operational environment where your application living and utilizing. You can think about, let's say, PC usage agent or web usage agent. An agent can even utilize a RAG or even connect to IoT devices, sensors, or even robotics arms. Each of these skills are listed in our guide, and as the slogan says, with great power comes great responsibility. When a developer chooses to implement one of these skills, you have to take in mind specific mitigations that you have to implement. So we listed around 10 different skills in our methodology, and obviously you can feel free to comment and add skills that you think that are missing in our document. So to sum up, when we are analyzing an application, we need to take in mind the skills, the architecture, the key components, and then to make sure that all the recommendations and best practices and countermeasures that we applied are spread around among the entire development lifecycle. A short recap of the threat landscape that we are dealing with, all taken from the threat and mitigation guide. Over here, you can see the memory poisoning, tool misuse, and goal manipulation threats, all directly connected to the key components. While cascading attacks, identity spoofing, and communication poisoning are all directly connected to the architecture of your application. And lastly, we have attacks like remote code execution that are directly connected to your skills. Let's say an application implemented code interpreter to execute code. It extends the possibility of an attacker to execute remote code execution. So now when we are fully understand the properties of the methodology, Vinita over here will demonstrate how to apply it.
Thank you, Dan. Quickly, does anyone need a QR code again? Or are we good? Because we'll be following different parts of the document now. Okay, all good? Okay. Cool. So first, we're looking at section 4.1, if anyone is following. Our recommendation is to always build with a single agent architecture, because you can always make your system more complicated, build over time. But starting off with a single agent architecture and then extending it to your use case is what we found the easiest. Most of our mitigations for our single agent architecture will also work for the multi-agent. And so the multi-agent is just an extension of it. So the way we'll walk through for the next maybe 5 to 7 minutes, I don't want to take too much time because I want to give you guys time to give feedback, is we'll walk through a few case studies for each of our architectures, talk about a few threats like what Idan spoke about, and then a few mitigations. So in this case study, we have a simple Slack agent, right? A Slack agent, what does it need? It needs to be able to send messages, view messages, understand them. There might be hooks, right? You might have hooks to GitHub and so on. And so, so that's a really simple example of a Slack agent. So you have multiple tools here, right? You might also have access to your calendar tool and so on. You have cross-session memory. So your Slack agent must also know like context, who you spoke to. So it has some short-term memory and also some long-term memory, depending on how you're implementing it. And so we can break down this into our architecture, and we can talk about threats in each and mitigations in each, right? So For our initial architecture, we have a shared memory, like we spoke about. It's possible that when your Slack agent is accessing your calendar tool, it needs to know, like, hey, based on this message, I need to make this, I need to block this calendar or book this meeting room, something along those lines, right? So here you have all the memory threads that Helen discussed in her thread model. And so, and then in the operational environment, we have, let's say a lot of companies have hooks from GitHub to Slack or GitLab to Slack. So every time you have a new PR, it sends you a message, right? If your Slack agent was vulnerable to like prompt injection and had access to some kind of code execution environment, the code that comes in via the PR, the head message, it can possibly execute within the remote code execution environment. So that's an example of an operational environmentality issue. And then in the dev lifecycle, we talk about like build time controls as well as runtime controls, things like schema enforcement, making sure you are you're enforcing schema, having strong input-output validation, guardrails, prompt patching. If you're if the risk in your organization is like the ability to take risk is low, you remember in SQL we had store procedures and structured inputs. You can do the same thing for prompts, right? You can collect the intent of the user and then have system prompts or like map intents to prompts on the back end. So your user prompt never actually goes to the LLM or the agent. And building on this, let's say we have now a multi-agent architecture. Right now, we have the same Slack agent, but now you have a calendar agent, you have a drive agent, access to like some room booking agent for your office building and so on. So like imagine a situation where your company requires you to be 25% more productive because the economy is not doing well now. So and so now they say you have to use agents and you like, this is the only way we're going to move forward. And so now with the multi-agent architecture, you have a lot more issues. So let's think about Copilot. I don't know, like how many of you have used the 20 different Copilots Microsoft released already? This is the 21st one. So yeah, so now so we have same thing, right? In our architecture, we have our memory issues, but now we have memory across various tools, right? Embrace the Red or Johan Reberger had a few threads out, right? So there was a Outlook Copilot tool plugin, whatever, that would summarize emails, and it had the entire context and memory of the user. So it was we are sending like text in the email that was like blacked out, so the human couldn't read. He was able to prompt inject evict Slack tokens because the agent had access to the memory. And now, if you had a shared memory, if the agent had access to other details about your calendar or about like your drive, it would be able to get information from other systems in your environment and increasing the threat surface. In our operational environment, we have API access, right? So we have calendar API here. What happens if you have some kind of DOS attack? It blocks out your entire calendar. There's so many other threats, and then it builds upon a single agent where we have schema enforcement, prompt patching. Same thing happens here, but now you have to deal with multiple agents talking to an orchestrator. And this architecture here would not work for swarm architecture. So we probably go with an orchestrator architecture. And so now you have to think about how to actually protect your orchestrator. Is your orchestrator another agent or is it a deterministic system? So you have architectural choices that you can make. And based on the choices you make, you have different mitigations. And our documents, I think we're in section 4.3 now, talks about various architectures in a multi-agent system and how to actually harden them. And finally, the elephant in the room that we haven't spoken about yet is peer-to-peer architectures. Google came out with a agent-to-agent protocol about, I guess, a month ago now. A few of us, along with Prashant, released a paper on it. But again, work is in progress. We would love to hear from you guys on this. So we'll spend the next like 20 minutes getting feedback, questions from you guys on how to improve this. But in a peer-to-peer architecture, you have either be a swarm, or it can be agents in one firm talking to agents in other firms. And so you have issues like remote discovery, delegation issues. So what happens if a lower privilege agent requests a task from a higher privilege agent? How do you ensure that the original requester's authentication context is passed along when you have multiple agents talking to each other? Because you can't always authenticate on the agent's context. Sometimes you must authenticate on the requester's context. So there's a lot of complexities when you come to peer-to-peer communication. So this part of the document is still work in progress. We'd love to get your input on this. Yeah, and so again, quickly, I don't want to take too much time. We can either choose decentralized trust or identity and trust, or we can have a more centralized, like a registry for agents and tools, and make the centralized system vend out credentials like just-in-time credentials and so on. Again, for our peer-to-peer communication, we have to ensure like our basic, like security guidelines are in, like encryption, authentication, authorization, like like for data storage. How are you ensuring like agent B is allowed to actually see the data agent A is sending to it. So you might have HIPAA compliance, FedRAMP. You have like once you get compliance into the picture, especially with multi-agent systems, it gets a lot more complex. And again, yeah, we have the same issues with build time, runtime. We are trying to provide some guidance on it. Again, very early stages, so hoping to hear some feedback. And now, again, this is a QR code again. We have the same form. The form also has links to the docs. If you want to comment directly on the doc, you can do so, or you can answer questions from the form. Now I'll hand it over to Rob, who will chair the discussion part of this. Just setting expectations. We want to hear as much from you as possible. We want to see what you guys are doing, what you guys want to see in the document, what you guys have seen, and how to improve our document. So handing off to Rob.
Are we good to advance? Yeah, all right. Okay. I was thinking through this, we should have made a game out of this. Whoever answers these the most gets to join the project. Okay, so throughout the doc, I know it was impossible to read like after first seeing it, but as you guys go through it, you'll see there are a lot of recommendations on how to secure certain components of the app. Things like guardrails, controls are in there. We'd love to hear from anybody who's brave enough. Of those who are building agentic apps, can you share what type of controls you're putting in place? That could range from things like build time tools, runtime tools, monitoring infra. All of those are covered in the doc. There are different techniques, but does anybody want to share their own experience and things that they've done? Yeah, go ahead.
Sure. So I'm really concerned about user data. So as a person who's involved in tech, I feel a responsibility to protect user data. And I think that right now, when we have these agent-to-agent flows, I don't see any real protection. Like if I share my data with Google and then they want to use an agentic flow outside of Google, what's stopping them from then sending my data across? So what I would like to see is some sort of user data-based resource token that then allows me to specify how it can be shared and allow me to real-time revoke the sharing of any data whatsoever.
So are you, to say it another way, are you saying almost like field level permissions, like as elements of allowing permission at the either field or document or object level per user in terms of saying what an agent can or can't do with any of my objects?
Yeah, I would see it wrapped within a user data object. And then within this user data object, it has a resource token that then says how long this is valid for. And then if it's been revoked. And at that level, you could even have a level of have a certificate attached to it. So if you don't have the, like if that backing certificate is no longer available, you simply can't read the data. Things like that, things really forward looking that are there to protect. And my concern is that AI is going to really create a large amount of functionality, but likewise, it'll provide that functionality for the good guys as well as the bad guys. So each piece of user data, the threat that it then enables within the bad guys is orders of magnitude. And so I think it's getting to the point where it makes sense to start protecting that user data. And by having these resource tokens at some level, then you can protect how it goes across these agent-to-agent boundaries. Yeah.
fact, we are discussing and thinking about this certificate-based mechanism in our agent naming service. This is an upcoming.
Yeah, we'll talk about it soon. Yeah. Go ahead. Yeah. Oh, sorry, go ahead. Yeah.
At the rest of the conference, they just talk right over you. So, you know, after Y2K, well, how many people know? Well, so 25 years ago, after Y2K, when we moved from, you know, M204 mainframes into a client server world, we were terrified about access management for humans. And something was created called identity and access management, where instead of just a few of us, we now had hundreds of thousands of users on our client server apps. And then when we moved to the cloud, we had millions of users, right? And what I would like to see you all start moving forward is we now need the version 2.0 of IAM, which is synthetic identity and access management. So synthetic being agents, right? So it's not a, you know, plug this gap here, plug that gap there. We need to actually just start the next version of the framework, you know, the non-human framework, the synthetic identity and access management framework. That's kind of where I'd like to see us go.
No, that's a great point. Because like we spoke about when a requester asks an agent something, how would the following agents know who yeah, you're right. Okay.
So we're also talking there is an OWASP protocol, non-human identities, vaccine identities. So that's an interesting project in itself, and we're beginning to talk to so we can have an option. But they're also
And I'll just add, I know, this morning in the, at the summit, at the, I think the red teaming section, Jason was talking about the need for moving authentication, not just to the agent level, but to the task level, which I thought was pretty interesting. There would be some cool things that come out of that.
That's what goes with the synthetic identity and access management, right? So, I mean, we're not reinventing the wheel. Those of us that raised their hand and knew what Y2K was, we invented that wheel. All right, and it was a lot of work. For everyone to come in, had these sessions, right? It was a lot of work and it took us several years to build that framework. And those of you that worked there, we went through this and now we need to do it again, just in the synthetic environment, right? So I think we don't have to reinvent the wheel. We know who we need to get in this conversation. And we need to think about it as the next generation framework, not piecemeal, right? So.
And that's where the conversation will be. I'm not sure when I think this I will make sure to consolidate the conversation rather than creating little projects that can
Right, exactly.
propagate their own things.
It's a larger framework, you know, for, you know, synthetic identity and access management. So it's not just an agent or a task, right?
Yep.
But I love your work.
Thank you.
So I'm a founder of Monster AI. What I see our customers doing, so there are many things. So first with guardrails, most customers do not let the user prompt get to the actual LLM. They'll do some type of refinement step, which is also good because users aren't good at writing prompts in general. So that's just good in general. For tool execution, so if you're deploying your AI application as a service, right? You have all the HTTP auth that we've done for the last 20 years. So you should secure your stuff that way. If you can pipe context into your agent or your agent framework. But if you can't, or like you're on a server application, tool middleware is something that's coming as a pattern, which is essentially wrapping your tools yourself and then doing like authorization yourself. And you can kind of pass that into your agents and stuff. We work with WorkOS, Clerk, and what's the other one? I don't forget, Auth0 or something. They're all trying to figure out synthetic identity, mainly because if no one's doing OAuth anymore and only agents are, they're going to go into business. So that is a huge thing that they're working.
Yeah.
So, yeah.
Yeah. Thank you for that.
Sorry, so I'm gonna ask a question that is for me kind of fundamental, like this, I kind of funny that I don't understand this. Maybe everyone else is doing that, but you know, in terms of when Karen talked about, you know, authorization,
And just, okay, and you know, my framework is, okay, if I'm writing services or microservices, I have all these APIs, and I could even go granular down to the API level, and define the token scope and stuff like that, right? That's what I thought about when I learned MCP. But now looking at this, it feels like I have all these agents that are talking to each other. I don't even know what I would be asking. So it's like, how would I know what authorization, what permissions should I be asking? Like, this agent is asking the next agent, or MCP is asking a bunch of tools. How do I define what is authorized and what is not? At what stage in the process? How do I define my policies? I guess I'll just
Yeah.
all of a sudden realize that this is a lot more complicated than I thought it was.
No, it is because like there's no winner right now, right? We're still very early stages. There's different. I've seen at least what I've seen is you can give the agent the caller's identity, right? Whatever the caller has access to, the agent has access to, or the agent has a subset of the caller's identity based on the risk. You don't want your Slack agent to be able to see your performance, like last year, like your work performance, or your salary details and things.
But what I'm saying is whether it's user or agent, doesn't matter. It's like, what is this original requester's permission? Like, my past experiences, I worked for Equinix, a data center company, and you know, hundreds of thousands of customers, and you don't know who from which company is allowed to order a rack or a router or a switch or a lake. You know, so our permission system is extremely complicated, and that's what we did it. But here it's really down to, I don't care if it's an agent or a user. What is allowed to do? Like in this case, when you're ordering a hotel or whatever, is this user allowed to get access to other things in the company? It's not clear. to
Yeah,
me
I mean-
because I don't know.
Yeah, I mean, I don't think there's a simple answer to this. It's a much complicated answer, but that's a good point to have just a section on like the interconnected, the problems in interconnecting agents and the authentication of it. The lovely lady said about having agent like synthetic identity. Maybe that will solve. Again, we don't have the answers yet. Very early stages. A2A just came out a month ago, so I think we'll see how it evolves, and hopefully we'll keep the document updated. But that's a good point. I think what we'll do is we'll try to, like, I would love to talk to you after, try to brainstorm, see if we can add something to the
I
document.
see this like service to service is a problem that people get with the microservice work. Right?
That one is an example from the audience.
Yeah, no, I agree with you. Yeah, will do. Any other questions before we find the audience? Yeah, go ahead.
Actually, I was gonna ask the question.
Yeah, go ahead.
We're making an agent, it's a single agent architecture. Essentially, what it does is it takes like a general sentence from person and generates a SQL query based off of it. Right, very simple, but it's very sensitive because you know it's gonna generate a query for you. It's gonna run. It can go as far as running the query for you, and even generate the code for analytics, like graphs and stuff. So essentially, in terms of like controls and guardrails, like using the person's access token becomes really important all the way through because it's a database access, right? Let's say FinTimes team might have more access compared to like a general person. So I have one question around it, right? So if we were to just, do we treat the agent as another internal service which can have access to a person's token? Or do we treat it as, you know, like a person who you usually don't disclose an access token, right? Another person. So how do we deal with that kind of situation?
Good question. We'll get back to you.
There is a fine grain access sample that can,
We got the gentleman over that chair.
Yeah, so, and maybe I guess you can consider two agent application and we consider the application next between them from an OAuth perspective, using different plans. Dot there would be. In that framework, I can have If we consider agents as applications and any agent-to-agent communication as an API call, I'm not understanding why couldn't we use OAuth and custom claims in order to have granular access controls between those two agents? I mean, we discussed OAuth a couple times. It seems like it's just been swept aside. It's like, well, somehow we can't use OAuth. Why not?
So I guess, I don't want to answer for the whole group. I'll give my opinion, but I would say like OAuth for human to agent, the initial authorization or like initial human to agent to tool makes sense. But when you're 5 agents deep or 4 agents deep, what are you authorizing on? Like whose identity? Like that's the question, right? Like you said OAuth, right? But like, what is the authorization server? What is the resource server? Like you need to like establish the standard OAuth protocol. So like you need to define what are the resources, who's going to be the authorization server for agent 4, agent 5. How do you know what is the authoritative authorization server then? Right.
I have some color info. Majority of also like scope for mapping, it's the cost related. It's not final related, right? The example I give is if you have access to one file in Google Drive, it has access to whole Google Drive, not just one file. And this is why the attribute-based access control or context-based access control go beyond the OAuth scope. You have something added that, but this is also not enough because this using the traditional policy information point, the traditional one, that's actually instrumented during the deployment time. It's static, but agent could be really dynamic. It depends on the task, specific task. So the identity really should be short-lived, ephemeral, I mean, and it has to be context and task-based, yes.
I can just speak. Basically, if we look back, the firewall and cloud. So basically, I think that's where zero trust kick in, right? The firewall idea, a traditional one, it doesn't work. But if you really think about it right now, we engage with ChatGPT. I think they can dig out for traditional thinking of you expose all the resource attack surface for hacker to draw the useful information could be changed drastically in the current AI environment. The reason is, think about the search engine. Right now, what I'm care about are all I pipe into that ChatGPT prompt. If I can synthesize all these answers, that's what I'm thinking and that's what I'm interested. That should you protect most because that's all I'm current daily life, right? So I think the current, and is that just actually to divide all these different agents and their corresponding access resource to summarize them to come up the most valuable information? I don't think so. It's just the traditional LLM that's everybody actually trying to attack this ranking and feedback has a huge problems. I think the agent generation AI, we just cannot think of the traditional way to actually attack the granularity level. And because the most useful information is coming from what I'm thinking and trying to guess what exactly what I'm trying to do. That's most valuable. Data security is. Well, by the way, I see a lot of people making it talk and how to teach. I think
But that's fine, it doesn't matter where we're from, we kind of have an issue here, that's the great thing about all we have so many people from different companies, it doesn't matter where we're from. So, are there any other questions or shall we, because we're running a bit out of time.